All right, so we're going to talk about inverses. This is going to go on page 42 when we're done. So inverse relations. We're going to talk about inverse relations and inverse functions and make sure that you can keep those two straight. Okay, so it says, what is an inverse relation? Okay, so an inverse relation is a relation that exchanges x and y and is a reflection in the line y equals x. Right. So our notation, the inverse of relation R, so it's a capital, like italicized R for relation R, is written as R inverse. Okay. So if I want to give the inverse of this relation, here is R. The inverse is just going to be, we exchange x and y, be -7, 0, then 2, -1, then -2, -4, then 3, 6, and that would be your inverse. We exchange x and y. Okay, so now let's talk about one-to-one functions, because this is where what we really focus on. Okay, so a function has a one-to-one relationship if the relation and its inverse are functions. So basically what this boils down to is this. Every relation has an inverse. Okay, all of them. Every relation you could come up with, there's an inverse because you can exchange x and y. Every function, you can exchange x and y, but it's not going to be an inverse function unless it's one-to-one and they're both functions. So I can take a function and exchange x and y and make another relation. That relation is not necessarily a function. So it's called one-to-one if the function and its inverse are both functions. So we'll look at some that are and some that aren't. So then there's a recall. Recall means, we already know this. Recall, the vertical line test is used to determine whether a relation is a function given a graph. Okay, so if you're given a graph, then you can tell by the vertical line test whether or not it's a function. We also have something that I mentioned, but we didn't talk about because we weren't ready for it, the horizontal line test. This is an important test as well because it's used to determine whether the inverse of a relation is a function. So I can tell by a graph if I have a function from the vertical line test. If I do the horizontal line test, that'll also tell me if the inverse is a function or not. If both of them are functions, it's one-to-one. So both the relation and its inverse must be a function in order to be a one-to-one function. Okay. So it says, determine whether the relationships are one-to-one functions. So we just look at the vertical line test and the horizontal line test. Well, if I drop the vertical line down on a line, we know a line is a function, right? And I can drop the horizontal lines in here. It passes the horizontal line test as well, so the answer is yes. It's one-to-one. Okay. So this here, can drop my vertical lines down. This is a function, okay? But when I drop the horizontal lines in here, it does not pass the horizontal line test. I should probably be using a different color for that so you can see that. Let me erase So I'm passing the vertical line test, right? I got that. Come in here and do the, because the vertical line test is passing because I'm just hitting it at 1 point each time. But then when I do the horizontal line test, it fails it because here it hits it 4 times, but it actually keeps going like that, so it actually hits it an infinite amount of times. So this answer is no. So here I know that this is a function, right? It's my reciprocal function, so I know that works. Okay. But if I do the horizontal line test, does that work? And the answer is yes. It's going to pass that horizontal line test as well. So this is going to be yes, 1 to 1. Here, this is a vertical line test. Yes, this is a function, right? It's a cube root function. And then horizontal line test, it passes that as well because that inverse would just be the cubic. So this is yes, 1 to 1. Right, so I have another line. It's a function, right? Passes that. Does it pass the horizontal line test? And the answer is no, because when I do that, that's at an infinite number of points. And so this would be no. Because when you take the inverse of a horizontal line, you get a vertical line, not a function. Then this one fails the vertical line test. Don't even have to worry about it passes the horizontal line test, but it fails the vertical line test, so this one is a no as well. Okay, so visually from a graph, you have the horizontal line and vertical line test. If it passes both, it is a 1 to 1 function, which means the function and its inverse are both functions. Okay, next page. So, talking about inverse functions now, because over there we were talking about just relations and possibly functions. So, notation, the inverse function of f of x is written as this. Oh, this. Okay, so, and then again, it's important to understand that not all functions have inverse functions. They may have an inverse relation, but they don't necessarily have an inverse function. So to find the inverse of a function, you replace f of x with y, interchange x and y, solve for y, and then rewrite it as the inverse of f of x. All right, so, but before we even do that, we're going to determine if it has an inverse, okay? Because if it doesn't have an inverse, then I don't have to bother. So we look at number 7. When we graph number 7, that's going to be a line, correct? It's a line. It's not a horizontal line, therefore it has an inverse. So I'm going to set this equal to y instead of f of x, right? Then I exchange x and y. So this is going to become 4y minus 8 equals x, because x and y just changed places. Then I solve for y. So 4y equals x plus 8. And then y is equal to 1/4 x plus 2. So the directions said to, So the directions said to find it, but I needed to rewrite it. I should have made this f, the inverse, x is equal to 1/4 x plus 2. This is how I really should have written it, and shouldn't have my box around that. There we go. And then it also says to state any domain restrictions. The domain of f of x was all real numbers. The domain of its inverse is all real numbers because they're both linear, and that's it. Okay, so now let's look at 8. So 8 is cubic, right? So a cubic is going to look like this. I really don't care what the actual function looks like, but I know the parent function looks like this, right? If I reflect that in the line y equals x, then I get this, right? I'm going to get a cube root function. So cubic function, cube root functions, yes, they're both functions, so it has an inverse, so I can solve it. So I set this equal to y. Exchange x and y. I'm actually, and then I'd like to get rid of that 1/2, which I was just thinking I could have done in the first step, but it really doesn't matter if it's the first step or the second step. I need to divide both sides by 1/2. Apply every y root by that is of 2x plus 2. Okay, so this is a quadratic. Reflect that in the line y equals x, I get this. Is that a function? The answer to that is no, because this passes the horizontal line test, it fails, it passes this passes the vertical line test and it fails the horizontal line test. So even if I didn't draw that, I know vertical line test fails the horizontal line test. It's not an inverse because it has an inverse relation, but that inverse relation fails the vertical line test. So the inverse is not a function. So this is no inverse. No inverse function because it fails the horizontal line test. Okay, this is my answer. All right, so then I look at this one. This is a reciprocal. So my reciprocal function looks like this. If I reflect it in the line y equals x, it's going to look the same. Plus, this passes the vertical line test and the horizontal line test. So since it passes both, that makes it a one-to-one function. It has an inverse. So I set this equal to y. I exchange x and y. 5 over y minus 8 is equal to x. Okay, so then I'm going to multiply both sides by y minus 8. So I get 5 equals x times y minus 8. Got to put that in parentheses so I don't mess anything up. I'm trying to get y by itself, so I want to get rid of x. So I'll divide both sides by x. So that gives me 5 over x equals y minus 8. Then I add 8 to both sides, so y equals 5 over x plus 8, which means the inverse is equal to 5 over x plus 8. Now we got to talk about domain restrictions. Okay, so my domain restrictions, so this is this, but I still have to talk about the rest because there are some domain restrictions here. My parent function, my domain goes from negative infinity to 0 and then from 0 to infinity, right? This has a transformation that moves it to the right 8. So it's going to go from negative infinity to 8 and then 8 to infinity. That's the domain restriction on f. However, that's not the same domain restriction here. The domain restriction here is just that x can't equal 0. Could I have figured that out before I solved it? The answer to that is yes. Because although this shifts over and the domain now goes from negative infinity to 8 and 8 to infinity, the range goes from there was no vertical translation, so it goes from negative infinity to 0 and then 0 to infinity, which means that the y value just can't equal 0. Well, guess what? When you do the inverse and you exchange x and y, you also exchange the domain and the range. So the range here was just basically that y can't equal 0, so the domain here that I have is that x, all values of x such that x cannot equal 0. And so I would have known that even if I hadn't solved that, because it's the range of the function itself. Okay, so now let's look at 11. This is a square root function. So my parent function looks something like this. It passes the vertical and horizontal line test, so it is 1-to-1. Set this equal to y. Exchange my x's and y's. So we get negative square root of y plus 2 minus 7 equals x. Okay, trying to solve for y here. So I'm going to add 7 to both sides. So I get negative square root of y plus 2 equals x plus 7. Then I need to get rid of this negative, so I'm going to multiply both sides by negative 1. So that'll give me a positive square root of y plus 2 equals negative x plus 7. Those parentheses are important. I need to then square both sides to get rid of my square root. So this gives me y plus 2 equals parentheses, negative parentheses, x plus 7 squared. Then move my 2 over, so y equals negative x plus 7 squared minus 2. So the inverse of f of x is equal to this right here. Okay, so now we have to talk about domain restrictions. Excuse me. All right, so my parent function looks like this right here. The actual function, if I was going to graph this, let's think about what's really happening right here. We would take this function, and this is going to reflect it in the x-axis, so it's actually going to reflect, it's going to have this, that type of thing if I just was to reflect it. And then after I reflect it, it's going to shift to the left 2 and down 7. So I'd have to shift to the left 2 and down 7, and then it has this kind of curve on it, like so. And this point right here would be, that does not look super accurate, so let me try that one more time. We don't have to be super accurate, I'm just trying to ballpark it, but negative 2, negative 7 is a little bit more dramatic like that. Okay, so this is at negative 2, negative 7. All right, so the domain restriction on the function itself, on this, right, is clearly your domain gives you this right here. From negative 2 to infinity is my domain. This would graph a quadratic, we should know that by looking, but a quadratic doesn't normally have a domain restriction, but we do here. It's the inverse. It's not the same domain restriction as this because it's not the same function, right? This is the inverse, which means it got reflected in the line y equals x. Well, the line y equals x is like right here, right? Plus, I exchange x and y when I do that, so that would be negative 7, negative 2, and it gets reflected up, it would look something like this, right? So now this is negative 7, negative 2. All right, so let's look at domain restriction. So the domain of this function, again, is from negative 2 to infinity. The domain of this function here goes from negative infinity to negative 7. Therefore, that means that x, all of my x's here, have to be less than or equal to negative 7. So let's see if I could have known that before drawing all this or even before doing this here. Well, remember, we are exchanging x and y. So since x becomes y and y becomes x, the domain becomes the range and the range becomes the domain. So the domain of my original function was negative 2 to infinity. The range was negative infinity to negative 7. So the range, which was your y values, all your y values become your x values here. So this range, that means all the y's would have to be less than or equal to negative 7, becomes your domain. So now that's why all of my x's are less than or equal to negative 7. Being able to graph your little parent functions pretty quickly to wrap your mind around what's happening is important. That's one of the many, many reasons why we're doing all of this graphing. Okay, so let's look at number 12. And so here, this is an absolute value function. So absolute value function looks like this. It passes the horizontal line test. It fails the vertical line test. So this has no inverse function. Okay, because it fails the horizontal line test. And there you go. All right, so no need to do any work. Don't jump in doing the work before you investigate stuff, or you might be doing too much work. All right, so now I want you to pause this, and I want you to try number 13 out for yourself. But like, for real, do that, because I'm not going to stop talking. I'm going to keep going. I need you to pause, give it a try, make sure you're doing it in pencil, in case it's not right, and then you can come back and watch this and see if we agree. Okay, now is the time to pause. All right, so this is a cube root function, right? Cube root function looks like this, and that is going to pass the vertical and horizontal line test. Therefore, I can do the inverse function. Set that equal to y, exchange my x's and y's. So cube root of y minus 9 over 4 is equal to x. Right? So I'm going to multiply both sides by 4, so I get the cube root of y minus 9 is equal to 4x. Got to get rid of the cube root, so I'm going to cube both sides. So when I do that, I end up with y minus 9 is equal to 4x cubed. Then I add 9, so y equals 4x cubed plus 9. That means my inverse function is equal to 4x cubed plus 9. Then I have to look at domain restrictions, right? So do I have any? Well, this domain is all real numbers, and the range is all real numbers. So when the domain and range switch, I get all real numbers. There are no domain restrictions. Okay. All right, so now let's look at 14. Okay, so again, I'd like for you to pause, try number 14 on your own, see what happens, and then come back and see if you can follow along with me and if we agree. All right, so this function is a quadratic. It would graph a parabola. However, we have a domain restriction on the original one. The domain here is only if x is greater than or equal to 0. So that means that it's going to look like this, right? That's the half of the parabola that I have, where all of the x's are greater than or equal to 0. That passes the horizontal line test and the vertical line test. Therefore, the function and its inverse are both functions. So I can set this equal to y, and then I can switch my x's and y's. So this is going to give me 3y squared minus 1 equals y. No, it equals x. Dang it, sorry. And then I'm going to solve for y. So this gives me 3y squared equals x plus 1. Divide both sides by 3, so I get y squared equals x plus 1 divided by 3. I'm going to take the square root of both sides. So I take the square root of both sides, and when I do that, I get y equals square root of x plus 1 over 3. So every time we introduce a square root, remember I've made a big deal. If you introduce a square root, you have to have plus or minus. But here's why we're not right here. If I have a negative sign out here, it doesn't directly affect my x. It actually directly affects my y's, correct? My y values in the inverse are my x values from up here. So since all I wanted were the positive x's up here, all I want are the positive y values down here. So I'm not putting a plus or minus. I'm only putting a plus, which means I'm not putting anything. If I did plus or minus, that's like when so if I have an actual parabola, the whole thing, and I reflect it, it looks like this, and it's not a function, right? And so if you take the square root and you don't do plus or minus, you only get this part. You don't get the negative y's, basically. And we don't want the negative y's. We only want the positive y's because we only had the positive x's. So this gives me this. So there is no minus sign there. Now, got an issue here because I have a 3 in my denominator with this square root, and that's a problem. So got to fix that. This is the square root of x plus 1 over the square root of 3. So I can simplify, or I can rationalize my denominator, square root of 3 over the square root of 3. Remember, when you multiply them, you can multiply inside. And I'm not going to distribute the 3 because we want things to be in parentheses when we're graphing and whatnot, so it's fine to leave it. So this is going to give me the square root of 3 times x plus 1 over 3. Which I could leave it like that, and there's nothing wrong with leaving it like that. But if I pulled this 3 out as a 1/3, then it's going to look more like something you could actually do transformations with, like so. Okay, and that is equal to y, so that is my function value, I'm sorry, my inverse function, and we will make that is 1/3 times the cube root of 3 times x plus 1. So let's talk about domain restrictions here. Now, when I drew this over here, this wasn't actually the parent, this wasn't actually this function. I probably shouldn't have just done this part. I was just kind of drawing that half of the parent function. So what happens here is that this gets vertically stretched, but then it goes down 1. So really, it's going to look more like this, right? And this point right here is 0, -1. So my domain of this function, the original one, is that x has to be greater than or equal to 0. My range is that y has to be greater than or equal to -1. So my range becomes my domain here. So it's not that my x's have to be greater than or equal to 0 here. My x's, which were my y's here, has to be greater than or equal to -1. Okay, because that was this range. If you're not sure about that, and you can graph this, we can look at this a couple of different ways, actually. We can look at this as, if I was to graph this, I know what the square root parent function looks like, right? Looks like this. Or if I don't even have to worry about graphing the parent function. If I'm going to reflect it in the line y equals x, like right here, then y equals x, x equals y, so that 0, -1 actually becomes -1, 0. And it looks something like this. So you can see that your domain of this function here, all of your x's have to be greater than or equal to -1. Okay, so think about the fact that x and y switch places. That means so does the domain and range. Don't just jump in and start doing algebra on stuff just because you can, because some of these are going to fail the test. So check out the horizontal and vertical line test. Make sure it's 1-to-1 before you start doing any work. You can handle this algebra. This is why I've been nailing you with this and telling you you've got to know how to handle things like this, because that's just a really minor part of what we're doing. The pre-cal part of this is the 1-to-1 and the inverse and the restrictions on the domains. But if you can't do the algebra that's behind it, then that's going to hurt you for sure. On the assignment you are getting today, you are doing the front only. Front only on the assignment. Do not do the back. We will talk about the back later. Actually, tomorrow.